Hi, algebra. In lesson 7 here, we're going to be finding the average rate of change, which is going to be very close to how we find slope. Here we go. To decide who we agree with, I'm going to first look between 4 and 6 p.m. This is what Tyler was looking at, and it dropped 8 degrees in 2 hours. So if it dropped 8 degrees in 2 hours, that would mean that it dropped 4 degrees per hour. And May is looking at the difference from 6 to 10 p.m., which is 4 hours. And during that time, it dropped 9 degrees. And so if it dropped 9 degrees in 4 hours, it dropped 2.25 degrees per hour. So it was dropping faster when Tyler had said between 4 and 6 p.m. Here we have a lot more data about the time, the hours since noon, and the temperature in degrees Fahrenheit for a winter day. And here we have the same data in a table. So these two things are showing the same information. When we're finding the average rate of change, that's going to be the same thing as finding the slope between whatever 2 points we're looking at. So in A, we're looking at noon, which is here, and 1 p.m., which is right here. I'm going to make myself a slope triangle, and I'm going to use both the graph and the table over here to figure out what's going on. So from here, my run I know is going to be 1, and let me zoom in here. My rise from here to here, I'm looking at the table. I know that it's going from 18 degrees up to 19 degrees. So right here, that rise is also going to be 1. So my rise over run is 1 over 1. Labels are going to be important here. My rise is talking about degrees Fahrenheit, and my run is talking about hours. So if I simplify this, this is going to be 1 degree Fahrenheit per hour. And that just means the temperature was going up 1 degree per hour. In B, we're looking at the average rate of change between noon, which is again right here, and then 4 p.m., which is this point right here. And I'm just going to draw a line connecting those. We are finding the slope between those 2 points. The rest of these points in between don't matter. One thing I didn't do earlier that I should do is I should put the coordinates for each point right there. It's going to make things easier. I'm going to make my slope triangle. I'm going to have it go the other way this time. It doesn't matter which way we go, but I'm going to put my distances on here. And I can see that my run here is 4. My rise, it's not going by ones. It's going from 18 up to 25. So that would be 7. So my average rate of change is just the slope. So it's going to be my rise with 7 degrees Fahrenheit over my run of 4 hours, which would simplify to 1 3/4 degrees Fahrenheit per hour. And it's positive, so I know it's getting warmer by that much per hour. Next, we're going to go from noon, so that same point, and then to midnight, which is way out here. And I'm going to label that as 12,7 according to our table. And I'm just going to draw a line connecting those. I'm finding the average rate of change between those 2 points, and our slope triangle will help us do that. My run is going to be 12, and my rise, I'm going from 18 degrees down to 7, so that's going to be 9, and it's going downhill, so I know that that's going to be negative. It dropped 9 degrees Fahrenheit over my run of 12 hours. And so I simplify that to negative 3/4 degrees Fahrenheit per hour. It means it's getting colder by 3/4 of a degree every hour. From 4 to 6 p.m., I labeled those coordinate points. I took those from the table to help us out. And then I'm looking for the slope between those 2 points. It went down 8 degrees from 25 to 17, and during those 2 hours. So rise over run right here, and I simplify that to negative 4 degrees Fahrenheit per hour. From 6 p.m. to 10 p.m., I labeled my coordinate points. I took that information from the table, drew my line, made my slope triangle, and I can see that it went down 9 degrees over 4 hours. So rise over run, and what really happened is it went down 2.25 degrees Fahrenheit every hour. So it was dropping faster between 4 and 6 p.m. And I can also see here that the line is steeper, meaning that it's going to be dropping more degrees Fahrenheit every hour. Now we have this graph looking at the populations of California in the blue line and Texas in the red dashed line. And we are going to estimate the average rate of change in the population in each state between 1970 and 2010. The first thing I did is on each line, I put my points at 1970, and then I had to estimate what the population was at that point in millions. So here's my 2 points there, and then again in 2010, and we are having to do some estimating here, so we're going to do the best we can with that. Remember that average rate of change is just a slope, so I made my slope triangle here, and I see that my run is 40, my rise is 14. Slope is always rise over run, and I'm also going to add on my labels. So the population increased 14 million people over 40 years, which would simplify to 0.35 million people per year. For California, I made my slope triangle here. I can see that the population increased 17 million people over those same 40 years. So rise 17 million over 40 years. And that simplifies to 0.425 million people per year. So we can see that California is increasing in population more quickly over that time frame. And what does each rate of change mean? And our labels really help with that. It just means that it's that many million people per year that the population was increasing by. In number 2, it's talking about which population grew more quickly. That means we're looking for the average rate of change. And we're trying to figure out which one has the higher rate of change between 1900 and 2000. You need to do some estimating here. For Texas, I estimated they were at 3 million people in 1900 and 21 million people in the year 2000. So that's an increase of 18 million people over 100 years. And so if you calculate that, you're going to have your rise of 18 million over 100 years, and it would be 0.18 million people per year. For California, I estimated 1 million people in the year 1900 and 33 million people in the year 2000. So that's an increase, a rise of 32 million people over 100 years. And so their average rate of change, rise over run, would be 0.32 million people per year. This is towards the end of your lesson summary. You'll see this graph right here. And this is just showing you how this formula right here is the same thing as what we do in slope triangles. You have the outputs of your functions right here being subtracted. Those are like your y values. That's how we find the rise. Then you have your x values of your functions being subtracted. That's how we find the run. That's what we've been doing over and over again. But if you're someone who likes a formula, there it is for you.